learning from your experiences, all things, and we are inculcating and also applying these which we have learned from last 12 years. Now it's the time to apply all the capabilities for our country to develop towards the science and technology as well as other things. Thank you very much, sir. Thank you very much. Now I would like to again Professor Dr. Ifikar Ahmed, Vice Chancellor Gomal University, to chief guest of our program. Sir, welcome you here. Professor Dr. Ifikar Ahmed Sahab.
Bismillahirrahmanirrahim. Awaz aa rahi hai?
Open your, okay, wow. Nice to see you, sir. Welcome here.
Good to see you. First of all, I'm very thankful to the organizers of the conference for organizing such a wonderful activity, especially Dr. Sajid Hussain Sayal, a dynamic leader, a young boy, and I'm sure that with his leadership at the Department of Materials and Metallurgy, that will touch the skies, inshallah. I'm very thankful to the worthy Vice Chancellor, Dawood Engineering University, Professor Dr. Faizullah Abbasi Saab. I'm also thankful to Professor Dr. Abdul Wahid Bhotto Saab, Prof. Vice Chancellor, and Zafarullah Khan Saab, who joined us today in today's session. I'm also thankful to the delegates who are here and who will be presenting their work. So thank you all for inviting me, and thank you all for being here in today's wonderful activity. Before starting, I will appreciate the organizers, and I hope that they will keep it on, inshallah Aziz, and they will do it again and again, inshallah Aziz, and organize activities like this. Let's start from advanced technologies, then we will go towards materials, because majority of the people today, majority of the people, they are from the materials and metallurgy community. So we start from a simple technology, then we talk about advanced technology, then we go and then we will be talking about importance of materials in advanced technologies. So simple machine is like when we talk about two or less simple machines. Like for example, we have a knife, or we have an axe, something like that. Those are simple machines. So with knife, we can cut vegetables, we can do many things. These are simple machines. Now, if 2 or 3 or 4 simple machines or technologies, when we put them together, that will make advanced technology. Like for example, like the microwave we have, like in microwave, you know that how many parts are there in that microwave. Similarly, we have electric iron, and we have jet propulsion machines, and then we have like all these beautiful technologies, including today's computer. So these are advanced technologies. There are more than 2 machines. When you put them together, they become advanced technologies. Now, when we talk about advanced technologies, this is important that whatever we see in today's technological world, this is the blessing of advanced technologies. When we say that the civilization is at the peak, so the civilization is at the peak because of the advanced technologies, and the main source of the advanced technologies are naturally materials. So these are the materials which make things work. If we talk about any technology, let's talk about like energy. So if we talk about energy, then we are talking about solar technology, and we are talking about like different sorts of renewable energy technologies. Similarly, if we talk about communications, then think about computer. We have this computer, then we have high performance computers, They are working across the globe. Then we have cloud computing, where, like you have data somewhere in USA, but you are using that and you can utilize it for different purposes. Similarly, the trains, like the fastest trains. Similarly, like the planes, like all these planes, like the commercial planes, and then we have the planes like the jets, the fighters and stuff like that. मेरी आवाज आ रही है या नहीं आ रही है? Hello?
Yes, आ रही है आपके पास. जी जी बिल्कुल क्लियर आ रही है.
So when we talk about all these technological blessings, and when we talk about all these, like blessing, technological blessings, these technological blessings are based on materials. So remember, when we talk about the computer, there was a computer. I remember that in 1995, I was at Solid State Center, Punjab University, and we had a computer that was like a very, very poor computer. So today my cell phone, that's more powerful than that huge computer I used in 1995 in Solid State Center of Punjab University. So this conference, the activity of the conference, I hope that this will connect researchers. This will provide opportunity for the students so they can approach to the persons with whom they can talk, they can collaborate, they can ask solutions of the problems they are facing. And at the same time, like this timely conference, like along with the connection, making connection between the researchers, the second main objective that we will be also looking at what we need to be doing for the future. What technologies we will be working on. For example, today, like in our group, we are working in hybrid, organic, inorganic, hybrid perovskite solar cells. So like similarly, there will be other technologies which we need here in our country. So the people who are working in those technologies can share those technologies. They are important with the researchers. So this way, we can encourage our researchers to work in the cutting edge. Thank you very much. I hope this conference will be a success. This is a success in the materials community. And I hope that everybody will enjoy this activity. And once again, I'm very thankful to Dr. Sial for inviting me. And I'm very thankful to the Vice Chancellor for inviting me for this event. Thank you very much.
Thank you very much, sir, for your time. You are really a very dynamic leader, and I have a personal friendship with you as well. And now I would like to say, invite again our worthy Vice Chancellor, and I want to get a permission to start our official program from the speakers. Sir, over to Dawood University Vice Chancellor. Sir.
There is no need for the permission, but I think in the convocation, I can say I declare the symposium open.
Okay, thank you very much, sir. Thank you very much. And now we are going to start our formal day with Dr. Muhammad Zahir Iqbal, Associate Professor in GIK in a Nanotechnology Research Laboratory and the Faculty of Engineering Sciences, Swabi, Khyber, Pakhtunkhwa. The topic of Sir Zahir Hussain Saab is a progression towards the next generation hybrid energy storage devices. So I would like to invite Professor Dr. Muhammad Zahir from GIK.
Assalamu alaikum. Can you hear me? Hello.
Zahir Saab.
Are you hearing me?
Yes, sir. Yes, sir.
Okay. Okay. Thank you very much for
I
your
welcome you,
invitation.
sir. I welcome you here again.
Thank you very much. And this is I'm thankful to you as well for the organizing and all the organizing committee for inviting me in this wonderful event. Without wasting my time, I will start my talk because I know that the schedule is very tough and we have to see the things very carefully. So I will start my talk and I will discuss all these things during the talk. So today I'm going to talk about the next generation energy storage devices, and I want to share. Can you allow me to share my slides?
Yes, sir. Yes, sir. You have authority to. You can share the slides.
Please. Okay. Then please let me check the talk. Okay, this one is. Are you? Is clear? Can you see my slides? Is it appearing? Okay, today I'm going to talk about the progression towards the next generation hybrid energy storage devices, and that is kind of an interesting field that
Screen को थोड़ा बड़ा कर दें, sir.
It's a full screen. I have a full screen from my side.
Okay.
So the topic I am going to discuss today is the progression toward next generation energy storage devices. You already told that I am from the Faculty of Engineering Sciences from the GIK Institute. So the major topic that I am working here are the few topics in which I am working. First one is the 2D materials and heterostructures. There is a famous material that in the 2010 from the Manchester group got the Nobel Prize on the two-dimensional materials. I have done my 2 PhDs on this work, one on the spintronic and quantum devices, and other one on the bioelectronics, two-dimensional material-based bioelectronic devices. And recently I am working on the electrochemical devices, in which we have the supercapacitors and the batteries, and I will discuss these ideas with you. I will share my ideas. In the supercapacitor, actually, when we discuss about this capacitors and batteries, so there are major component in the industry. If you see in the energy sector, there are two kind of devices normally used. One is the energy conversion devices, in which we have a solar cells is most commonly used devices, and second one is the supercapacitors and battery are used normally storage devices. So in the supercapacitor idea here is, in some cases, if we discuss about the power or energy of the energy storage devices, some of the devices are especially used for the low power devices, such as our laptops, our mobile phones, and some of our devices like vehicles, we need like intermediate power and intermediate energy. In some cases we need high power. So we can differentiate these devices in different forms. Suppose if you have batteries and we have capacitors, in all cases we have kind of we can clearly distinguish between the supercapacitors or capacitors and in batteries. In the case of batteries, if because there are many students are here in this talk, I will try to explain very briefly, and so I hope students can understand easily. The first thing that is, if you suppose what is the battery? Battery actually is kind of low power device, and it has a high energy. On the other side, if I consider the capacitor or supercapacitor, this one is a high power device but low energy devices. Means in the supercapacitor we normally study the power, means high power devices are normally used as the capacitors, high energy devices are supposed to be the good batteries. If I'll explain in detail what is the capacitors and battery, it is very simple. If you have a two kind of race, one is like a marathon race, another one is a sprint race. In one case, we need a more power. Suppose in the race, a person athlete who want to cover the distance in very shorter time, like 100-meter race, kind of a sprint race in which he use all of his power to cover that distance. And in the other case, if you have 5,000, like a marathon race, 5,000-meter race, and you don't need to use a lot of power, but you need a consistency and you need energy, and you can stay for the longer time. So kind of marathon race is your battery behavior, and for your sprint race is kind of abrupt behavior, or you can say the supercapacitor behavior. So our idea here is, if we can, because if you see the advantages of these two devices, one is supposed to be a high power devices and other one is high energy devices. If we combine, means one benefit is can be taken from the each device, and if we can merge together these two devices, then we can come up with the solution with high power and high energy devices. So if we combine supercapacitors and battery in a one device, we can get the high energy density, high energy, high power, and high stability. So this is the major disadvantages in the batteries nowadays is the life cycling and stability are low power. If we choose this kind of structures, we can tackle those problems, and we can get the high energy density, high power density, as well as the high stability or high life cycle stability. So there are many methods to investigate these kind of behavior, and then if most of the chemists, so they probably know what the electrochemical characterization technique, in which we do the cyclic voltammetry, we do the galvanic charge discharge measurement, GCD, and electrochemical impedance spectroscopy. Let's go to the behavior of the characterization of these devices, how we can estimate, how we can define our devices have very good capacitor or very good battery. In the case of supercapacitors, in the case of supercapacitors, we should have the cyclic voltammetry graph like a rectangular shape. One region, red color, is representing the charging, and the blue region is representing the discharging of that capacitor. And when you see the GCD curve, means galvanic charge discharge contribution, then we have a linear increase in charge and linear discharging behavior. But in the case of batteries, we have a very different phenomena. Is kind of Faradic reactions takes place, and we will have a sharp reaction peak, oxidation peak, and then the reduction peak.
सर आपकी स्लाइड्स जो हैं वो मूव नहीं कर रही स्लाइड्स।
अब कौन सी स्लाइड शो हो रही है?
अब पहले पे ही है हम सर, पहली स्लाइड पे ही हम।
इस तरह से हो रही है। लेट मी चेक अगेन।
यस सर, क्योंकि हम पहली स्लाइड पे हैं तो इस वजह से वो काफी
नहीं अभी भी नहीं शो हो रही।
शो हो रही है आपकी स्लाइड, सिर्फ पहली स्लाइड्स पे ही हम लगे। अभी फर्स्ट ही स्लाइड आपकी है।
लेट मी चेक अगेन। मैं इसको रीशेयर करता हूँ।
सर
स्टोरेज
आप शेयर करेंगे तो आप शेयर करें सर।
शेयर करने की ये देखिए अब डिस्प्ले नहीं हो रही, शेयर तो कर रहा हूँ। आपके पास स्लाइड्स मैं आपको साथ शेयर कर दूं, आप इधर से ऑन कर दें, मेरे से शेयर नहीं हो रही स्लाइड।
जी सर ये भी बेहतर है, आप मुझे
मैं आपको मेल कर देता हूं। पहले शेयर हुई थी आपके साथ ना?
फर्स्ट पहली स्लाइड से शेयर हुई थी, उसके बाद जो है ना उसमें सिर्फ आपका इंट्रोडक्शन लिखा हुआ था, तो उसके बाद जो है ना नहीं हुआ था।
ट्राई करता हूं इन टाइम।
सर जफर साहब काइंडली यहाँ पे देखें, मैं स्क्रीन शेयर कर रहा हूँ, यहाँ पे आप थोड़ा सा देख लें, आपको आइडिया हो जाएगा।
मैं स्क्रीन शेयर फर्स्ट स्लाइड शेयर हो रही थी तो उसके बाद वाली शेयर नहीं हो रही थी, इट मींस देयर समथिंग।
अच्छा देखें यहाँ पे अब आपको स्क्रीन नजर आ रही होगी। यहाँ आप जो है MS टीम के ऊपर जब आप जाते हैं,
जी वहीं से शेयर हो रही है ना, ये देखिए ठीक है, मैं वहीं से शेयर कर रहा हूँ ना, कि मैं वहीं से शेयर कर रहा हूँ और मेरा शेयर हो रहा है, इधर से मुझे शो हो रहा है कि शेयर हो रहा है, लेकिन आपको डिस्प्ले पहले मेरी आप इस तरह करें, मुझे दोबारा से ऑप्शन देना कि वो शेयर करूँ मैं।
अच्छा देखें ये ऑप्शन आपके पास ही पूरा कंट्रोल है। यहाँ जो आपके पास ये शेयर का ऑप्शन आ रहा है, यहाँ पे जब क्लिक करेंगे तो आप भले स्क्रीन को भी शेयर कर सकते हैं और पावर पॉइंट प्रेजेंटेशन को भी कर सकते हैं। यहाँ पर जब आप प्रेस करते हैं तो ये एक यहाँ पे कर्सर टाइप बना होता है शेयरिंग का ऑप्शन।
ये देखिए ये वाला यहाँ यहीं से मैं कर रहा हूँ मेरा, लेकिन नहीं शेयर हो रहा ना, ये हो रहा
हो रहा है सर। अब शेयरिंग जो है ना हो रही है, आपकी स्क्रीन आ रही है।
अच्छा चलें
नीचे जो बॉटम में आप चले जाएंगे तो आपके पास
सर आप जो है ना वो स्लाइड्स सेंड करते हैं, मैं यहाँ शेयर करता हूँ।
It's like a smart devices in which we needed like optimum power and optimum energy. There are many applications in this kind of games, like that you could use these kind of devices. Suppose if you have kind of smart vehicles in which we need average power and average energy, we can utilize these kind of devices for that purpose. Now the idea behind is it possible that we could make this kind of like a hybrid devices in which we will have kind of a battery behavior as well as the capaciting behavior. I mean, we should have a high power and high energy. If we talk about these kind of devices, we should be very careful to analyze these kind of devices, the drawbacks due to these devices, and what should be how we can get the maximum advantage by using these kind of devices. So suppose if we will have these kind of devices, how we can handle these kind of technical issues. Please share the slides if possible. So in the case of batteries in general, we will have kind of Faradic reactions, means there in the case while in the case of supercapacitor we will have a kind of physical absorption at the surface. So these are two different phenomena. If we come up with a solution with one device, with a hybrid device, that will provide you the new direction as well as the new phenomena and mechanism inside these devices. Because on the one side of the electrode, if we are using one electrode from the batteries and one electrode from the capacitors, then the idea behind that one side is like a Faradic reaction, like a chemical reactions take place. On the other side, we will have a physical absorption. So when we will get the overall behavior should be kind of an intermediate state between the capacitors and the batteries. सर साहब स्लाइड्स नहीं हुई ऑनलाइन अभी, आपने शेयर नहीं की? मेरी आवाज आ रही है आपको?
जी डॉक्टर जाहिर साहब आपकी जो है वो डाउनलोड हो रही हैं स्लाइड्स, डॉक्टर साहब कह रहे हैं शायद स्लाइड्स हो जाती हैं तो वहाँ पे शेयर कर देते हैं.
Okay, it's fine. Then this kind of devices, when we talk about the batteries and capacitors, then after the capacitors and battery, the analysis is very important. How much contribution comes from the one electrode is very important part. Whether the capacitive part is more dominant or the diffusive, which means battery grade part is more dominant. We can clearly analyze this kind of behavior, and we can say that if we need, in some cases we needed high power, in some cases we need high energy, then we can tune our devices accordingly. If we needed like a high power, relatively high power devices, then we can take the advantage of the capacitive electrode. If we need the high energy, then we can take the part from the energy side electrode. So this contribution can be easily accessed by utilizing one of the model in which we can easily detect the parameters. But then the again thing is how you can take the cyclic stability. Suppose if you have a battery, you have a mobile phone battery, how many times you can charge and discharge? Means 500 times or 1000 times. After that, what will happen? Your battery will be dead. The reason is the cyclic stability, that after so many times charging and discharging, your battery will be decreasing their efficiencies. So but in the case of capacitors, if we can charge the capacitors thousands of times, 100,000s of times, and then you can discharge, the effect will be minimum. The efficiency of the devices will not affected in the case of capacitor. But in our case, if we use one of the capacitive electrode and one is the battery grade electrode, then ultimately the performance, at least some contribution is coming from the capacitor side, that will help to enhance the cyclic stability of stability, charging and discharging stability of the device for a longer time. So these are the major parameters. There are major, you can see the directions that we are following, and we are developing these kind of devices by utilizing different kind of materials. One electrode is, one device, one side is fixed, that is the activated carbon electrode that is normally used for the supercapacitors, but the other part is we are trying with the battery grade materials, we are using some oxides, metal oxides, and we also tried with metal sulfides and metal phosphates, and we are tuning the properties, and we want to make a stable device that could help to find. And we made very, very delicate devices that are working well. We can turn on the lights, small lights, LEDs, and some small electric motors, and it works well. And all these devices we are making at atmospheric conditions, means we are not using any kind of clean room technology. Even we can develop these kind of devices at room temperature or room pressure, atmospheric pressure. These are the possibilities that we could explore in the future. These are the new ideas, and people are only starting the work on this kind of fields, because this was, if you see the literature, not a lot of work. If you go before 10 years, you cannot find this kind of hybrid devices that can provide you the maximum output. And secondly, the thing is the mechanism. Mechanism, very important parameter, because when you have these kind of devices, your mechanism will be totally different from the capacitors, individual capacitors and individual batteries. The reason behind that, you will have kind of a dual phenomena takes place at once. So that is very challenging point that we are working on it, because when we talk about these kind of things, the important thing is how the capacitive and diffusive is actually the battery side part, how the capacitive and diffusive processes take place at once. That is very important parameter. So we are extracting the parameters of the capacitive part and the battery grade, means diffusive part, and we are trying to to fix these issues and want to analyze the mechanism behind these kind of phenomena. If we talk about the batteries, in some case we will have a diffusive contribution is more dominant. In which one electrode, it is not very easy or very simple that we can say that one part is very dominant, or we have a 50-50 contribution from the both sides. It is not, because both electrodes are different in nature, both phenomena are different in nature, and when we have both phenomena in one system, then the system becomes a very complex system, and we are analyzing these kind of systems. And the next part that we will I will discuss in the slides once slides comes, the part of which material could be suitable. We are finding new kind of material in which we will get the both phenomena, both behaviors, and both kind of advantages in a one material. That is another new direction. Suppose if we are normally lithium ion and sodium ion batteries are normally used for our battery technology, but when we talk about some sulfides, some phosphates, some magazines, in that case, what will happen? The idea here is, if you will have both phenomena in one material, why we are not using that material? Why we need the capacitor material separately than the battery grade material? If some kind of materials will have a kind of same phenomena, means some dual nature, means some contribution from like a capacitive contribution and some contribution is a diffusive contribution, why we are not using these kind of materials? Or in general, you can say that we are exploring those kind of materials that will provide you the better power and better energy for these devices. If you have a question from the presenter, please continue, because I am just waiting for the slide. Once slides come, then I can clearly explain the things. The same things I am going to discuss in the slides. Can you show me the slides if possible, please?
Yes, sir. सर लग रहा है आपकी स्लाइड्स बहुत हैवी हैं, तो इस वजह से डाउनलोड होने में उनका मसला आ रहा है. Anyway,
डाउनलोड नहीं हो रही, दोबारा सेंड करो.
नहीं, डाउनलोड तो हो गई, वो ओपन नहीं हो पा रही हमारे पास. तो बहरहाल आप कंटिन्यू करें. मैं कोशिश कर रहा हूँ, हालांकि आपकी जो ईमेल थी मैंने फॉरवर्ड भी कर दी है कि इनको ओपन करें.
I will share in the PDF if possible, if you need it.
अगर दोबारा पॉसिबल हो आपसे, हाँ दोबारा आप शेयर कर दें, और उसी स्लाइड के नंबर पे
टेक्नोलॉजी इन पाकिस्तान. बस कंटिन्यू करते जाए, मैं स्टेप बाय स्टेप बताता जाता हूँ, आपको जरा बता दीजिएगा, जस्ट नेक्स्ट करते जाइएगा. Yeah, I was discussing this one. This part is actually, yes. Can you go to the previous slide, please? Previous slide. Slide number 4, I guess. Yeah, this one. In the case of hybrid devices, see, we have a capacitors and batteries. And in the case of capacitors, if you see on the left side, we will have kind of supercapacitor in which we have a high power and low energy. And on the right side, we will have a low power density and high energy density. Means battery has the capability for high energy density devices, high energy devices. But the power, on the other hand, if you see the capacitors have the high power density. Suppose. I was discussing these kind of things, that if you have two kind of race, one is marathon, one is the sprint race. In the case of sprint race, we need a very If we need a high power for a short distance, means like 100 meter or distance need to be covered in a very shorter time, we need a high power. In the case of marathon, on the other side, you need a very low power, but you need a long stability, kind of a high energy devices. We need like batteries. So one possibility is that we can combine these two devices, one benefit from the batteries, one benefit from the capacitors, and by merging these two devices we can make the super capacitory, kind of super capacitor, the combination, the merging of the chemistries of the batteries and the super capacitors, and that will provide us high energy density, high power density, and the high stability. Can you go please in the next slide? Next slide, please. Yeah, this and next slide. Please go to the next slide. I want to skip these slides now. Yeah, this one is the comparison of the batteries and capacitors. In the case of capacitors, you see the capacitors need the output of the cyclic voltammetry should be like a rectangular shape. And in the cyclic voltammetry for the batteries, you should have our oxidation and reduction peak that you can see on the right side. In the bottom, on the bottom side, we will have a kind of charging and discharging of the capacitors and the batteries. We will have a linear relation in the case of capacitor. We should have a non-linear relation in the case of battery. So we can predict the behavior of the device during the characterization. I mean, what kind of electrode material is behaving like a capacitor or behaving like batteries. If you see on the graph on the right side on the top, that we will have the linear graph for the capacitors and the supercapacitor, and but the non-linear discharging for the batteries. We will have a non-linear phenomena, means we will have a kind of a reduction peaks and reduction process takes place, and we will have a non-linear trend. Next slide, please. So the new idea is when we can categorize these kind of behavior in three different types. First one is kind of electric double layer capacitors, in which we will have purely rectangular output in the cyclic voltammetry. In the second case, we will have a kind of intercalation and some kind of Faradic reactions takes place, but not purely Faradic. There is a contribution, some Faradic contribution, some intercalation, and you will have kind of an irregular shape of your cyclic voltammetry. This is known as pseudo capacitor. And the third part is the Faradic reactions takes place. Purely, if we will have a purely Faradic reaction takes place, then we should have only a sharp peak. There should not be any kind of area under the curves. And in the figure G, you can see that you will have a kind of area, kind of some capacitive behavior, and some kind of a battery type behavior. Means we will have a combined effect. We call this kind of behavior as like a Faradic dominant behavior. In these kind of materials, we can tell that we will have both the power and energy should be greater, or you can relative to the other two types. And this is our point of concern, and we are focusing this kind of material in which we will have some capacitive behavior and some diffusive behavior. Next slide, please. So, how we can compare the capacitors and pseudo capacitors? In general, we call that if we will have a rectangular shape of CP, cyclic voltammetry, that should be kind of capacitive behavior. But in the similar case, if you have some kind of behavior rectangular, but the material is not the carbon-based material, like not the activated carbon, not the graphene, not the carbon nanotube. If this kind of material is not present in our device electrode, then like a manganese oxide shows this kind of behavior, then this kind of output is represented as a pseudocapacitor. There are a lot of debate on the pseudocapacitor behavior, but I'm not going to discuss here. But some people are not agreed with this kind of behavior, that whether this is electric double layer behavior or the pseudo behavior. But this is another debate. We can this kind of topic can be discussed later. But suppose we have two shapes. Like we have one picture. I'm showing in two picture. One is like a Barack Obama, and other is Alham Anas. If you see the pictures of these two people, from the first sense, you can see they are likely to be similar. But behavior, but is similar. Like we have two graphs having a same behavior. Looks similar, around like more than 90% similar. But when you see the origin of these two people, both are different. One is from Malaysia, one is from US. Means the property, the origin of your materials will definitely tell you the quality of your output. Similarly, our red and black graph is representing here. One is the activated carbon-based material is showing the same behavior as the magnesium oxide. But just looking on the graphs not always tells you the exact determination of the properties of your device, but definitely we should also look at the origin of the material that we used for this study. Next, please. Next slide, please. So, in the capacitors, I already discussed this one. I'm going to skip this one because the behavior of the supercapacitor should be kind of rectangular. In the case of battery, should be kind of like a peak, like a Faraday reaction. If we combine these two, then you will have kind of a semi-rectangular shape. Semi-rectangular shape can be obtained. In the last C figure, you can see. And similarly, the GCD behavior will be also follow the same trend. Next slide, please. So initially we can do two kind of measurements. One is like a 3 electrode assembly measurement for the testing of the electrode, and then we can make the real device in which we will have one electrode from the carbon based and one from the battery grade material, and we can combine and we can sandwich these two electrodes, and we can make the 2 electrode assembly. The next, please. Please skip this one. This one is the methodology that we could use for the synthesis of this. Next, please. So we can also impedance spectroscopy is kind of an important parameter that can tells us the diffusion, capacitive, and the resistance of the electrolyte and the resistance of the electrolyte and the electrode interface. This is a kind of interesting insight of our experiment that provides us the behavior of the electrolyte and the interaction between the electrolyte and the electrode, and we can see that whether it is well compatible, or they are providing like a less resistance, or they are providing a high resistance that affects the overall properties of the devices. Next, please. Next slide, please. So this one is the combine effect. Combine, and the important part is, this is very interesting, that how you can estimate the contribution from each side. On the left hand side, if you have like in the middle, you can see the like a semi-rectangular shape behavior, not really the Faraday, not really the capacitive behavior. Means we have a kind of a combination from the battery side electrode and combination from the carbon side electrode. So what we can do, we can estimate the contribution from each electrode, whether the battery grade is dominant or whether the capacitive electrode is dominant. The shade and the colored region inside that graph is representing like pink color is representing the capacitive contribution, and the remaining part is light pink is representing the diffusive contribution. There is a model that we could implement that model, and we can easily extract these parameters. Next, please. So no, in some cases we can clearly identify this contribution, but in some cases, if you see in the graph, last graph, you can see that the model is not fitting very well. So this is a discrepancy in our model and our experimental data. Now we are working on that to find the solution why in some cases for some materials it works well, in some materials it is just not following the strategy that we apply. So the model is the behavior actually is not very simple that we can easily extract one component, because both are during the reaction both contribution from the both electrodes are in kind of a complex system that provides like a very that we cannot easily extract the capacitive contribution and the diffusive contribution from that system. So we are working and we want to extract the each and every parameter that will provide you the exact mechanism of the device, and what are the missing parameter actually in this model. We are trying to extract that will help to estimate the new devices and will help to provide the new directions to implement these devices for future technology. Can you go to the next slide, please? So like we can make the real device, we can estimate the device, and we can make kind of a device. And in the second graph, you can see in the B graph, one black curve is representing the behavior of the capacitors, and the red graph is representing the behavior of the battery grade. And when we combine, we can make kind of hybrid devices which will have, if you see in the last graph E, you can see the capacitor and the behavior is better than the capacitors and behavior is better than the batteries. So we can see that we can, in the intermediate state in which we can benefit from the battery side electrode as well as from the capacitor side electrode, and we can overall enhance the energy and the power of the device. So this is the strategy that we are implementing. And if you have this PPT slide, then you can also, in the next slide, you can see. Can you go to the next slide, please? So like these are the contribution that you can extract from the each. And if you have asymmetric devices or you have asymmetric devices mean one electrode is carbon, other one is the battery grade. In the symmetric devices, if you mix these materials and we make the same devices, and we can also study these kind of phenomena and how it works. So we have various recent papers on this one. If someone is interested, they can visit our website. Can you go to the next slide, please? Time is short. I'm going to skip. Okay, this one actually I have added the video. I don't know. It is. I think it is a PDF file. Cannot be run here. If it will be like a PPT file, then we can see that we can turn on the electric motor, and we can also turn on the LEDs. That works well. Means our idea works well here. We can utilize these for the future. Mean we can establish this kind of like a systematic research, and we can utilize for the industrial purpose. Next slide, please. And this is a summary actually that will tells you to what the idea is, like how you can make the hybrid devices that will provide the direction towards a new technology, kind of smart technology that will provide the both benefit like high power devices and high energy devices. Means instead of we can replace the capacitors and battery with the one device that could helpful for future kind of industrial technology, like a smart technology that could be utilized. Next slide, please.
Sir.
Next slide, please. I think these are the recent papers that you can see in my website, and also there are the recent papers in 2020. There are many papers or more. You can just visit my Google Scholars account or my university account site. You can find. If someone have any question, please let me know, because time is too short. I am going to wind up my talk, and thank you for your time, and thank you very much from my side.
Thank you, Zahir Sahab, for your time and very Great presentation. I have many questions, but I want to ask from the audience if they have one or two questions, so we can take from the audience. Okay, Shahzeb Khurshid. Can you open the mic of Shahzeb Khurshid, sir? And your paper are really very amazing in a very high impact factor journals. So I'm very great friend of you, and with respect to your contribution in the research.
Thank you very much.
Okay, Shahzeb, you have a question?
Oh, yes, sir. I will want to. It was superbly elaborate everything regarding the nanotechnology and the work of this Professor Zahir and Dr. Zahir. Actually, I could not see the slides at the proper time, so I skip a lot of questions which have in my mind. So I really appreciate the work of the Dr. Saab. So actually, I want to ask the question about the quantum dots sensitized solar cells. So I think I will ask the question personally from Dr. Saab from his channel. So because I have skipped the questions.
Yeah, sure. You can contact me on the WhatsApp. Even you can email me. I can respond to it because I am in the group that Dr. Sajid has created. I mean, you can pose the questions, or you can just send me the personal message. Then I will be happy to answer the question.
Oh, thank you. Thanks a lot, Doctor.
Thank you very much from the all participants. Now we are going this time from the Dr. Cusrow Dubash, from the Chief Academic Officer, Lampro Mellon IT Solutions from Lahore. So we are welcome here, Dr. Cusrow Sahab. Because of the shortage of time, we are going to give a chance to another our keynote speaker. Sir, over to you, Sir Cusrow Sahab. Sir Dubash, hello. Hello. सर आपको आवाज आ रही है मेरी? Oh wow! Welcome you, sir. We welcome you here. सर की माइक, सर आपकी माइक बंद है. आपकी माइक बंद है सर. सर की 1 मिनट सर.
सर काइंडली आप वहां से अपने सिस्टम से ऊपर राइट साइड पे कॉर्नर पे एक माइक का ऑप्शन आ रहा है, उसको ऑन कर लें काइंडली. एक अनम्यूट कर दें. राइट साइड पे कॉर्नर पे टॉप पे चले जाएंगे तो एक माइक का आपको जो है वो मेन्यू नजर आ रहा है, उसको अनम्यूट कर दें. Yes, we can hear you, sir. Thank you.
All right. Okay. Let me share my slide. Thank you for this opportunity. Let me share my slides.
Thank you, sir. And we are, you are most welcome here. And thanks a lot for giving us some time.
Yeah, pleasure. Okay. My presentation is the instructor as a quadrilateral, and if you are an instructor right now, it will be good for you. If you are potentially in the process of becoming an instructor, it will be good for you too. If you are a student, I recommend you keep one of your instructor in mind as we go through this entire presentation. So, let's see what this means. What is a quadrilateral? We should all be familiar with that. It's a four-sided figure. And I'm showing you 6 examples of four-sided figures, and you have to choose one. Okay, so keep a paper and a pencil with you. You'll have to do some workings. Choose one of the quadrilaterals that you think you are. And through the presentation, we will see whether you were right or not, and what this quadrilateral thing about a teacher really is. So everyone select one, any one that you think you are. Next, why quadrilateral? 4 sides, and each side is an attribute that is important for instructors. The attitude of the instructor, the knowledge base of the instructor, the skills that the instructor has, and the instructor's management. All 4 of these attributes are essential to becoming an effective instructor. We will look at each one, but keep in mind that all 4 are essential, and that is why we are talking of a quadrilateral. Again, most of our instructors are very good with number 2. Knowledge, content knowledge, no problem. It's the others, the attitude, the skills, and the management that they need help with. Particularly, this is the 21st century. Just knowledge and content will not suffice. Skills are absolutely important and essential to teach. And 21st century education is all about providing the right skills to our students. And so, excellence will be required in all 4 areas. Most instructors will need to work on 1, 3, and 4. 2, I think if anybody needs help and needs to work on number 2, you are already in the wrong profession. So let's see what all make an instructor's profile. Of course, the person. All instructors bring themselves to the teaching learning scenario. And as a person, you bring your personality, your attitudes, and your beliefs into the classroom or the lab. So your person, your entire being is one part of your instructor profile. Then what do you teach? And we are looking at skills. We are teaching skills, okay? And under teachers, there is only skills. If we go to the next piece, which is content, there we have knowledge, concepts, and applications. Okay, we should be providing that, but we should be teaching the skills. If we are teaching knowledge, concepts, and application and forgetting the skills, we are not doing 21st century education any favor. And then you need to be effective, and you need to be effective with your management. All instructors have a dual role to play. We instruct and we manage simultaneously at the same time. And therefore, an instructor's profile needs to include all 4 pieces for effective teaching to happen. So let's look at the first element, personality. Personality is, number 1, self-awareness. Are you aware of your own self? Are you aware of your own strengths, your own weaknesses? That's essential. We are human beings, and no one is 100% perfect. So self-awareness is absolutely critical. Then interpersonal skills, because teaching, there are students, there are other instructors, and how do you interact with each other is critical. And how do students interact with each other also? The interaction is not just between the teacher and the student, or the instructor and the student, it is also between different students. So what kind of interpersonal skills do you bring with you to the teaching scenario? Attitude towards change. Many of us were educated in the 20th century, and we are teaching in the 21st. We need to change. And so what is your attitude towards change? Do you embrace change? Do you believe in change? Do you think change is essential in today's teaching scenario? What is your perception of learning? Is your perception of learning really just transmitting, letting the next generation know what you know? That's not good enough in the 21st century. Learning is very different today in the 21st century. So your perception of student learning needs to change as well. And then sensitivity to the context. Every institution, every organization has its own context, has its own ambience, has its own feel, and how sensitive are you? Whether you teach in a rural setting, in an urban setting, in a suburban setting, you teach in a private organization, you teach in a public government organization, that sensitivity to the context in which you are teaching also includes the sensitivity to your student population. Our students come from a variety of settings. How do you deal with that diversity and bring about unity in your classroom? Next is skills. What skills? When we talk of skills, what about your own language skills? The language in which you teach. Primarily, we are expected to teach in English. In many cases, we go bilingual, and in some cases, we may also have a third language or a different dialect to deal with. But what language skills do you bring to the teaching learning scenario? And then number two, sensitivity to the learner's language. Don't expect learners to come language prepared. They will not be. Okay, so you need to be sensitive to the learner's language. Our job as instructors is not to impress the students with our language ability, but to come down to the students' language ability to help them learn and then make them progress, develop, and grow. Balancing support and challenge. The status quo is not going to work. You will need to support the so-called weak students, the slow learners. You will need to challenge the bright learners. How do you maintain a balance between the support and challenge that you as instructors are required to provide in the classroom? What about planning? Every session you take needs to be planned. You need to plan on why you are teaching, what you are teaching, and more importantly, how you are teaching. And that is number 5, variation in teaching. Do you have different methods that you use? Do you do group work, independent work? Do you use technology? Simply talking and going away, lecturing is not the best mode of teaching, especially in the 21st century. So you need to be aware of what variations you have. How do you develop more variations? How do you bring in more changes and differences in your teaching in the classroom? Knowledge, which is of course content, and as I've said earlier, our instructors should be very good at this. Mastery of content. Do you know your content inside out? And not the content that you studied, the content that is available for students today. Are you up to date in your reading? Are you up to date in where your content area or your discipline is heading? What kind of materials and resources do you use? A textbook alone is not good enough, especially at the university level that we teach. So what additional materials, what additional resources do you find? Do you bring to the classroom? Do you use and have students learn that learning is their responsibility? Do you have objectives for teaching? Why do you teach whatever you teach on a particular day? It can't be because it's in the syllabus. It can't be because it's part of the curriculum. It can't be because it will be on the exam or test. Why do you teach whatever you teach today? What is the learning outcome for the student? Then quantity versus quality. How much do you teach in whatever time you have? We have to understand that an academic year is not 12 months. An academic year is 8 months or 9 at the most. So what do you do in that time? How do you balance the quantity that you have to teach and maintain the quality at which you are expected to do the teaching? And then number 5 is understanding. See, a lot of times we instructors, we come into the classroom, we give the information we are supposed to give, and we walk away. Giving the information alone, transmission, is not good enough anymore. Have the students understood? Did they get what you were trying to say? Did they get it at the standard at which you wanted to deliver your talk or lecture? How do you check regularly for student understanding in your classrooms is critical to knowledge. Finally, management, and classroom management is a critical issue even in higher education. Time. Is your teaching efficient and effective? Do you use time to the best advantage? If you have a 1-hour class, do you teach for 60 minutes or do you teach for 45 and you think you're done? Control. Who controls your class? It should be you, but with student input at higher education level. Do you have strategies for controlling students? Do you have strategies for classroom management? That's the repertoire of strategies that you need. What works for one student may not work for another student, and you may need to look for something else. Are you proactive or reactive? Unfortunately, a lot of times instructors tend to be reactive. Something happens in the classroom and we react. We need to be proactive and see why we need to provide for taking care of students and not waiting for some situation to happen and then react, but being proactive about the situation. And then, are we fair? Do we treat all our students the same? Fairness and justice is absolutely critical. It doesn't matter who you are, where you are from, what your social status is. A student is a student, and fairness is absolutely critical. So, if we look at these 4 attributes, attitude, skills, knowledge, and management, where the 4 circles intersect in the middle is where effective teaching is happening. So you see, the opportunity for effective teaching is very small. It's very narrow, unless the overlap among the circles expands. And that is absolutely possible, and it depends on you as the instructor. So let's find out what quadrilateral type you are. Let me warn you, you will need to be honest. We will take all 4 of these. We will look at 6 statements for each of these 4 attributes, but you must respond honestly to the 6 statements. The first one will deal with attitudes, and the Likert scale is shown at the bottom. 1 is never, 2 is rarely, 3 occasional, 4 often, and 5 always or most of the time. So let's see. I hope you have your paper and pencil, because you'll have to note the numbers you honestly give yourselves. The first statement: I respect the confidential nature of matters relating to students, parents, and institution personnel. Give yourself a score, 1 to 5, for that first statement. Confidentiality is absolutely critical in education. 2, I refrain from derogatory remarks and use discretion in remarks about students, teachers, or institution matters. In other words, you don't downgrade anyone within the human resource element of education: students, instructors, and other institution personnel. Mark yourself on a scale of 1 to 5 for that statement. 3, I participate willingly in in-service activities designed to stimulate professional growth, exhibit an interest in continuing professional growth. Just because you have a degree doesn't mean that is the end of your journey for learning. You need to continue to learn. Things are changing rapidly, particularly with education. So scale yourself 1 to 5 on number 3. I take pride in teaching and am supportive of the profession. If you are not excited about teaching, if you don't love the students, you're in the wrong profession. So give yourself a score 1 through 5 for number 4. 5, I demonstrate cooperation in areas of assigned responsibilities within the institution. As instructors, our job doesn't end with teaching. We may be on committees, we may be asked to supervise something, we may be doing research, and so a lot of this is assigned by the head or the dean and whoever it is assigned from. Do you cooperate? Are you interested in other things beyond just classroom interaction with students? So scale yourself 1 through 5 for number 5. And the last one for attitude, I believe in education the student comes first, even ahead of the curriculum, the syllabus, and even the instructor. In education, the student is number 1. If there were no students, instructors wouldn't be needed. So don't consider yourself as number 1 in education, okay? The student must be number 1. Scale yourself if that's what you believe, 1, 2, 3, 4, or 5. These are 6 statements for attitude. Let's move to knowledge. Again, it's the same Likert scale. Let's go to the 6 statements for knowledge. I prepare lesson plans that are appropriate and consistent with established curriculum. Now, I prepare lesson plans should be I prepare and use lesson plans. A lot of times we look very good on paper, but in reality, what we see is very different. So scale yourself for number 1, 1, 2, 3, 4, or 5. Number 2, I provide opportunities for review, reinforcement, and enrichment regularly. Now, these 3 terms, review, reinforcement, and enrichment, mean different things. Review is for everybody, all students. Reinforcement is for students who are weak or slow. Enrichment is for the bright students. And we have these different types of students in every classroom, no matter what we teach. So do you provide opportunities for all 3 of these? Review, reinforcement, and enrichment. Scale yourself 1 to 5 for number 2. Number 3, I demonstrate unusual creative ability and awareness of new subject field developments. This is because of technology. Through technology, with technology, new fields are developing in every subject area, in every discipline. Are we aware of that? Are you aware of that? Being aware of new subject areas, in other words, what's the job market for 2025? It's not going to be as the job market of 2020. Are you aware of that? Scale yourself 1 through 5. Number 4, I can select and use instructional strategies applying Bloom's taxonomy and other appropriate criteria. Now, Bloom's taxonomy is one. There is Solo taxonomy, there is Deefink taxonomy, and there are some others as well. But Bloom's has stood the test of time since the mid-1950s. Even now in the real world, Bloom's is used. Are you using it? Are you aware of what Bloom's taxonomy is? It's a hierarchy of thinking strategies. Are you using thinking strategies in your teaching? Do you allow students the time to think, which simply means, do you allow time for students to use their own heads? Scale yourself 1 through 5 for number 4. Number 5, I can create well-structured and varied assignments, quizzes, and tests. Again, more than one way of doing things. There's more than one way of teaching. There is more than one way of designing assignments, quizzes, and tests. Do you do variations even in your assessment activities? Scale yourself 1, 2, 3, 4, or 5. And 6, I integrate higher order thinking skills, pose challenging questions, and conduct stimulating discussions whenever possible. Now, whenever you do any of these, higher order thinking, challenging questions, or conduct stimulating discussions, the student has to be the independent learner. It cannot be you giving directions. How much of that happens in your classrooms? 1, 2, 3, 4, or 5. Scale yourself. And with that, we will end the knowledge base. Next will be skills. Same Likert scale, 1 through 5. Number 1, I use English correctly for instruction. Be honest, English is not our first language. A lot of us have degrees from the outside world where English is the native language. And if that is true, then your English should be much better compared to others. So do you use English correctly? It's not just do you use English, do you use English correctly? On a scale of 1 through 5, scale yourself. 2, I maintain instructional momentum, give clear directions, do not overdwell. What this simply means is as you transition from one activity to another, you're not wasting time. The momentum of a class, the momentum of a talk, the momentum of a lecture, the momentum of an activity is maintained because your directions are clear and you don't overdwell. What can be done in 5 minutes, you don't need to take 15 minutes to finish. So scale yourself, 1 through 5. 3, I convey support for students by using techniques such as providing encouragement, lowering concern levels, dignifying academic responses, and using language free of sarcasm, ridicule, and humiliating references. Over here, the important point is dignifying academic responses. The student may give a wrong response. That is not your opportunity to degrade the student. What do? Do you dignify the incorrect response given by the student? Scale yourself, 1 through 5. 4, I demonstrate enthusiasm and passion for my teaching, and it wears off on my students' learning. If you come with a smile to the classroom, if you are enthusiastic, if your body language shows passion for your job, it will reflect on the students' learning. Are you able to pass your enthusiasm for teaching on to your students for their learning? Scale yourself, 1 through 5. 5, I can effectively diagnose instructional difficulties. Students will have problems. All students will not get everything at the same time. How do you deal with instructional difficulties? Scale yourself, 1 through 5. 6, I provide students with specific evaluative feedback and use mistakes made by them as learning opportunities. See, we as instructors are there because students will make mistakes. If students never made mistakes, they wouldn't need us. So mistakes are opportunities to teach. Mistakes are teachable moments. Mistakes are not chances for the instructor to demean the student. Scale yourself, 1 through 5. And then the last one, management, the 4th attribute, it's the same Likert scale, 1 through 5. I demonstrate ability to monitor student behavior. Monitoring student behavior makes one proactive. When we don't monitor student behavior and something adverse happens in the classroom, we become reactive. So scale yourself, 1 through 5 for number 1. 2, I make sure institution property is respected by students, room is neat and used purposefully. In other words, whatever your institution provides, do you use it purposefully before asking for additional facilities? Scale yourself, 1 through 5. Number 3, I love my students even when they are goofing off, which means when students are not doing what I expect them to do I still love them? If not love, do I at least like them still? And we should. We've goofed off. I've goofed off also at times, okay? Students will be students. So scale yourself, 1 through 5. 4, I talk to and counsel with students rather than punishing them. Young people today need someone to talk to them, to listen to them, to counsel them, to help them. Punishment is not for the 21st century. It is not going to work in education. Mark yourself, 1, 2, 3, or 5. 5. I tend to be proactive instead of reactive in dealing with management issues in my classroom. In other words, do you foresee some adverse situation and prevent it from happening? Or do you wait for some adverse situation to happen and then react? Scale yourself 1 through 5. And the last one, I am fair and consistent in applying consequences against students' misbehaviors. You cannot treat different students differently. 2 students who've done the same mistake should be dealt with in a fair, consistent manner. Mark yourself 1, 2, 3, 4, or 5. So now you should have a total of 24 markings. Let's go. Add your 6 scores for each attribute and make a rough plot. You can see on your screen, I'm sure plotting is easy, so just add your 6 scores for attitude, knowledge, skills, management, and whatever the score is, plot it. Once you've plotted your scores, join the 4 points, and you should have a quadrilateral. That's what a 4-sided figure is. It has 4 points, 4 corners, 4 vertices, and 4 sides. So whatever your quadrilateral is, let's see. Which one is it? What does your quadrilateral look like? It may be one of these 9 I've shown here, or it may be something very different. Okay? So look, figure out what your quadrilateral is. It could be lopsided, it could be bisided, it could be 4-sided, same measures, it could be any shape, but identify what your quadrilateral looks like. It may look like a funny shape and you may actually be laughing at the quadrilateral you've created for yourself. That's okay. So here we go. If your scores were the same for all the 4 attributes, you came up with a square. If you came up with a square, is your square small or is your square large? Because that's how you will develop and grow. If your square is small and you have a square, you're on the right track. All you need to now do is see how you can expand that square. If you did not get a square, where were you low? Were you low in attitude? Were you low in knowledge, skills, or management? Those are the area or areas you need to focus on and try to improve. So I hope many of you got a square. Even if it was a small square in the middle, learn, grow, develop, expand that square for yourselves. Now, as a square, you are in balance because all 4 attributes tend to be more or less the same. You're in rhythm because everything is the same. You're in harmony. You are well-rounded. All 4 attributes are well-developed for you. You are holistic, which means you focus on the 4 aspects of teaching, not just one. In rotational symmetry, which means it doesn't matter whether attitude comes first or knowledge comes first or management comes first. If you rotate it, you still have a square. And multidimensional, because these are 4 dimensions, 4 attributes of teaching, and that makes you a multidimensional instructor. Square teaching, teaching as a square instructor, is when the worst student in your class writes down your name as his best teacher on the timeline of his life because he doesn't get into trouble in your class as often as he does in others. The worst student, even the worst student in your class, loves you because you are a well-rounded, holistic teacher with all 4 teaching attributes developed. As a square teacher, you are also having a student come up with a better way to solve a problem in your course, even though you've taught the same course for 5 years. What better reward for a teacher than a student who does better work than you? My students do better work than me. They should. If they're doing as good work as I do, I'm only producing clones. Doesn't help. Let your students show you they are capable young people and enjoy, celebrate their doing stuff better than you do. It is also leaving your institution late on a Friday night, exhausted, but knowing deep down that you made a difference during the week with some of your students. If we are not making a difference in young people's life, teaching, instructing is not just passing on content, it's changing lives. And finally, being told by your rector that you're doing a great job, being told by your students that you're doing a great job, and not believing that you're doing a great job. No matter who tells you you're doing a great job, don't stop. Just because you're being told you're doing a great job is not the ceiling. Move beyond that. Every time you hit a level on the bar, raise your bar. Keep improving yourself. That's when your students will also keep improving. So, whatever you've come up with as a quadrilateral, if you've done honestly the surveys that we went through, hopefully you know where you are good, continue with that. You know where you need help, what areas of the 4 aspects or attributes of teaching you need to work on, keep doing it. If you came up with a square and you were a small square, figure out how you can expand that square. And if you're already a big square, help others to become big squares. Good luck with your instructing with your students. Good luck with your teaching. Good luck in helping shape Pakistan's tomorrow. Thank you.
Thank you very much, sir, for your great presentation. Okay, if anybody have a question, he or she can ask from the Dr. Saab. Even you are ever great personality of Pakistan and very favorite personality of Pakistan Higher Education Commission as well. And we love you all, sir.
Thank you.
Your contribution is too much for our country and for the educational institute. So, अगर किसी के पास सवाल है तो काइंडली मीर मुश्तबा लगारी साहब. Okay. Mir Mustafa Lagari sir. Okay, you can ask your question. Can you open the mic, Mustafa?
Yes.
Okay.
Yes,
okay, Mustafa.
Mir Mustafa.
Please, Mir Mustafa. Please, your question. जी लगारी साहब. Okay, sir. और सुना आप ठीक है sir? तबीयत सही है आपकी?
Fine, TikTok, good.
And how about your opinion about this all scenario?
Well,
Because
so far
more
so
than-
good. I hope
And
this will
more
go
than
well for today and
near
tomorrow.
200 people also listening you your experience.
Thank you, thank you, thank you for the opportunity.
I'm really very grateful to you. I have no words to admire your contribution, and you always voluntarily available for Dawood University and for whole Pakistan.
Thank you, thank you.
Ji, thank you so much, sir.
Okay, good luck.
Now I'm going to invite our next presenter, Dr. Shumaila Ashraf. Recently, she have done her doctorate degree from School of Chemistry and Chemical Engineering from Beijing Institute of Technology, China. So I want to invite her here on the respective topic of emerging materials and their contribution towards science and society. I welcome you, Shumaila, here. Please, over to you. जी जी डॉक्टर साहब आपको आवाज आ रही है डबलिंग स्पीकर बंद कर दीजिए
Dr. Shumaila, kindly unmute yourself in the MS stream. Then we will
yes, sir.
Yes, we can hear you now.
Welcome, Doctor, here in Dawood University of Engineering Technology. So, what see you now? Ji, Doctor.
Assalamu alaikum and hello everyone. My name is Dr. Shumaila Ashraf, and today I am here to present my talk on emerging materials and their contributions toward science and society. I'm really thankful to Dawood University of Engineering and Technology for inviting me to this symposium, which is based on national multidisciplinary and advanced technologies and allied fields. First of all, I will give my brief introduction and educational background. I have done my bachelor's from Ph.D. Education Center, Chashma Miawali, and I have done my master's and MPhil in organic chemistry from Department of Chemistry, Quadrilateral University, Islamabad, Pakistan. And recently, I have done my Ph.D. degree from School of Chemistry and Chemical Engineering, Beijing Institute of Technology. And the main focus of my research work in Ph.D. was basically on emerging porous materials and their different applications, especially environmental applications and their energy storage applications. The contents of my today's presentation includes the introduction to different emerging porous materials and their my research background and directions. And especially I will focus my talk on synthesis of germanium-based anionic coughs and their exploration of their applications, such as in energy storage devices and their applications in environmental air pollution removal. Finally, I will conclude my presentation, and I will also show some future perspectives of my research work. First of all, I will give introduction about some emerging porous materials. We know that porous materials are divided into three main classes, which are based on different type of building blocks. The first type of class of materials which emerged from inorganic materials such as inorganic nanoparticles, and they give rise to some of the extended frameworks, which were also known as the zeolites. Zeolites are aluminosilicate minerals, and in the past they were the breakthrough materials, and they have been used for a number of applications such as catalysis and adsorption. The second major category which I will discuss in this presentation is about the hybrid material. Hybrid means they are composed of organic and inorganic material, inorganic building units, and they have been derived from 0D coordination clusters and then 1D coordination polymers, giving rise to extended 3D frameworks, which are also known as metal organic frameworks, because they are composed of metal parts and organic part. The third is composed of the organic building blocks usually, and they started from the natural products and then from 1D organic polymers to some porous organic polymers like HCPs, and they have been emerged through the different series and give rise to 2D covalent organic frameworks and also 3D organic frameworks, which are also known as 3D COFs. These different materials, they emerged through different times, starting from 1950s. At that time, zeolites were very important and breakthrough materials. And then the two main important classes of material which I will discuss here are metal organic frameworks and covalent organic frameworks. These frameworks are usually reticulated or synthesized through the different building blocks. In case of metal organic frameworks, the building blocks are some inorganic metal-containing clusters and organic linkers. They combine together to form 3D extended patterns, and which are repeated into different dimensions to give rise to the MOF framework. And they are composed of metal-oxygen bond, and they are hybrid of rigid inorganic material and flexible organic linkers. And they are mostly 3D in their structure, while in case of covalent organic frameworks, they are mainly composed of the organic constituents. These organic constituents combine together through different condensation reactions, and they remove some water molecule to give rise to these extended frameworks. These extended frameworks are lighter than metal organic frameworks because they are composed of light elements like carbon, oxygen, boron, nitrogen, and silicon. And unlike MOFs, they are composed of strong covalent bonds. Whenever we talk about metal organic frameworks or reticular chemistry or covalent organic frameworks, we also need to we cannot forget the name of Professor Umar M. Yagi, who is the pioneer of this reticular chemistry. What is the reticular chemistry? Reticular chemistry is actually a new field of organic chemistry which is concerned with the stitching or weaving of molecular building blocks through these strong bonds to make open frameworks. Umar M. Yagi is recently the chair professor of chemistry at UC Berkeley, and he is also an elected member of U.S. National Assembly of Sciences. His most recognizable work includes the design and production of these classes of compounds or frameworks, which I have mentioned here, and also known as MOFs, COFs, and also ZIFs. These frameworks have very high surface area, which make them suitable for a number of applications. For example, MOF 177 have a surface area of 5,640 meters square per gram, and they have very low densities. Here I also want to mention MOF 5, which is very first MOF, and it has an exceptional surface area of 3,000 meters square per gram. And this MOF was also published in Nature in 1999. Another breakthrough MOF, which is MOF 200, and it was synthesized and published in 2010. And this MOF, only 1 gram of this MOF has such a high surface area of 10,000 meters square per gram, which is equal to 1 US coin. But it can be equal to the one Zucker field. It means that just 1 gram of MOF, which seems to be so small, equal to $1 US coin, is can cover up a whole Zucker field. So it shows that these MOFs, although they show that they have in a very small quantity, they have a very high surface area, and which give rise to interesting and important applications of these compounds. I will discuss some of the general characteristics of MOFs and COFs. They can be easily synthesized by varying just temperature, solvent, or reaction time. They have very high porosity and surface area, which make them suitable for a number of applications. And they have exceptional chemical and thermal stability, which is the plus point. And they can be used efficiently for a number of applications. And they have variable structure. Their structure and properties can be varied only by changing different side chains on the linkers. And another important property is that they have tunable pores. It means that their pores can be engineered, or their pore surface can be engineered by introducing different type of functional group on the linkers or adding different type of metal ions. Due to tunable pores, they can host various guest molecules like hydrogen and methane storage. They can also be used to selectively absorb some molecules like carbon dioxide. They can also capture and trap some volatile organic compounds like compounds of nitrogen dioxide and compounds of sulfur like sulfur dioxide, and they can also trap some of the particulate matter like PM 2.5. They can also capture the solar energy, and which can be used to convert this energy into the fuel cells, and they can also be used to purify the water. Here I will discuss one of the recent example of these framework materials, which is the use of these MOFs or crystalline nets to harvest water from the desert air. Umar Yagi and his group has recently used two of the MOFs like MOF 801 and MOF 303, and they used these MOFs to create water harvesting system, because these MOFs are very thermally very stable and they absorb a lot of moisture. That's why they have used these MOFs in this water harvesting system, and they have designed a device in which they have placed a MOF inside a case.
आपकी जो है हेलो डॉक्टर शुमाइला, आपकी जो है पीपीटी नजर नहीं आ रही. सॉरी टू इंटरप्ट यू. काइंडली
Yes, sir.
उनको दोबारा शेयर कर दें काइंडली अपनी पीपीटी को. Okay.
Yes, sir.
Okay. Oh,
It's
great.
okay?
Okay. Keep continuing. Yes. Thank
Okay.
you.
Recently, Umar Yagi and his group has devised a very novel water harvesting system from the desert air. We know that in the desert, there is a scarcity of water, and desert air is it contains less moisture. It is very dry. So in such a condition, it's very important to devise some efficient energy harvesting process that can be used to store water under these conditions. So Umar Yagi and his group has used two type of MOFs like MOF 801 and MOF 303. Both of these MOFs are very water stable. They are very thermally and chemically very stable, and they absorb a lot of moisture. That's why they use these MOFs to generate such type of device. They have put this, so in this device they have put the MOF inside this water sorption unit, which was covered by this case condenser. So at the night, this case, the lid of this case was open to absorb the humid air, and during the daytime, when there was a sunlight, then they closed this container to create a closed system. And when sunlight falls on this container, the moisture absorbed by this MOF was just dissolved inside the container and was given out in the form of moisture droplets at the bottom of this system. So this whole cycle was divided into two parts. One cycle is the saturation of MOF, and the second cycle, which is concerned with the release of this humid air into this container and then condensation back into the water. So all this process is divided into these two cycles, and in order to make this process and this water harvesting system more efficient, they have just connected some solar cell panels which power a heating system, and they also power a fan to make this water harvesting cycle more efficient. And the MOF 801, it gives rise to 78 grams of water per day and night cycle, while 0.45 kilogram of MOF 303 produce 105 gram of water under the lab condition. And they have also employed this whole water harvesting system in the desert environment of California. Another important application which of the MOFs and COFs in the future technologies, they are used in the electrical vehicles. Like I have mentioned here, the new Mercedes-Benz F125, which was unveiled in a motor show in 2011 in Frankfurt. This was basically powered by hydrogen, and it has a revolutionary hydrogen storage technology and a storage unit which was structurally integrated within the body of this vehicle. So this vehicle is environmental friendly with no emission, and it don't depends upon the expensive fuels like gasoline. So how does the MOFs and COFs can be used within such type of vehicles? As MOFs and COFs have a high surface area and porosity, and a small amount of them can absorb a large amount of gas. So they can be used in a very small or limited space to store or capture our hydrogen. So they can reduce the problem of space occupancy, and they are very efficient to absorb and store hydrogen. So they can also increase the efficiency of the storage of hydrogen. And as we know that the hydrogen is in the form of gas, so in order to be used in the such type of vehicles, they can be pressurized at high pressure, or they can be stored under a very low temperature. So by using the MOF and COF technologies within these hydrogen storage units, we can also tackle with the problem of using large cryogenic tanks. And we also know that MOFs and COFs are also important constituents of the emerging lithium-ion batteries. So in the future vehicles, these lithium-ion batteries can be used to increase the efficiency of such type of vehicles and to commercialize them. These products, these type of batteries will be more efficient and more powerful as compared to the lithium sulfur batteries. So researchers are also doing work to increase the hydrogen storage ability, as well as to increase the power efficiency of such type of electrical vehicles through using these MOFs and COFs into such type of electrical vehicles. So apart from these applications, there are also some other emerging applications of these materials, and these materials can be easily tuned through their structural changes or variation in their structures, and can be used into different applications like sensing, carbon capture and sequestration, and different renewable energy devices, and also environmentally toxic pollutant capture. I have also summarized a list of different companies which are working on the MOFs and COFs. So these emerging materials can also be commercialized, and they can be future materials for different type of products. I will focus here especially on covalent organic frameworks, which is the major part of my PhD research work. And as I already explained, that covalent organic frameworks are entirely composed of the organic constituents, and these organic constituents, when joined together through different dimensions through condensation reaction, they give rise to either 2D structure or 3D structure. And on the basis of the charge, these covalent organic frameworks are categorized into 3 parts: neutral framework, cation covalent organic framework, and anion covalent organic framework. This anion covalent organic framework will be the major part of my next discussion. Anion covalent framework have a backbone which is entirely composed of the some building units with a negative charge on it, which is counterbalanced by some cations. Like in this case, I have displayed here, it is a ICOF with a spiroborate linkage, and it has an anionic backbone, which is counterbalanced by lithium cations. And some of the properties associated with this ICOF is that it is highly stable toward water and basic solutions, and can absorb a large number of hydrogen and methane. So it can also be a future material for hydrogen and methane storage. And due to the presence of the lithium ion, it can also conduct, and can also be used as unconducting materials. Another examples which I have displayed here is 3D anionic silicate covalent organic framework. This framework has a hypervalent octahedral silicon node, and these nodes are connected through tritopic linker or a hexahydroxy triphenylene. And this COF is also very important from the perspective of ion conductivity. Different type of linkers have been utilized for the synthesis of these COFs. And when these different linkers, they are connected through different dimensions or different symmetric combinations, they give rise to an extended framework in 3D or either 2D fashion. How these frameworks are synthesized? These frameworks can be synthesized through very easy and facile methods. Some of these methods which I have summarized here are mechanochemical synthesis, which is a room temperature synthesis, and it uses manual grinding. The second one is the sonochemical synthesis. And the third one, which is also a very efficient synthesis process, is microwave synthesis. And solvothermal synthesis, which is most commonly used method in the COF synthesis. And another method is ionothermal synthesis, which usually require high temperature, and also requires long reaction time. And the last one is the light promoter synthesis, which use the abundant light as energy source. And this type of synthesis also improves the crystallinity of these reactions. After the synthesis, whenever we synthesize a new MOF or COF, we have to characterize it through different type of characterization techniques. And I have summarized the major techniques which I have used during my research work. And these includes the PXRD, solid state NMR spectroscopy, and FTIR. These three are the basic characterization techniques which are used to characterize a new structure of MOF or new structure of COF. While morphology of such type of materials was characterized through field emissions, scanning electron microscopy, and transmission electron microscopy. And the other important property associated with these extended framework or porous material is the is to analyze their surface area, their pore properties, which was analyzed to our gas adsorption unit, which is also known as quantachrome R2 IQ, and the thermal stability of such type of material, and was analyzed through thermal gravimetric analysis. And while the different elemental contents was analyzed by ICP, AES, and XPS was used to detect the presence of different type of metal cations. Specifically, I will discuss here about the ion conductivity of these COF materials. As these COF materials have a fixed crystallographic structure, so we can introduce different type of cations within their structure, and they can be very efficient ion conducting pathways as compared to the conventional polymer-based electrolytes, because in conventional polymer-based electrolytes, they are very flexible, so they create a hindrance in the path of these ion migration. As compared to the COF-based ionic conductor, they have fixed channels, so they facilitate the ion movement through these channels. So COFs can also be very good candidates for ion conductivity, and they can also be used as a solid state electrolytes in the future batteries. Their ionic conductivity can also be enhanced through post-synthetic modifications. These post-synthetic modifications includes mechanical shaping of the COFs, preparing COF nanosheets, and making their thin films and membranes. And another way to enhance their ionic conductivity is introduction of different type of polymer fillers or polymer salt complexes. After the ion conductivity, another important aspect associated with the anionic COFs is their affinity to absorb different type of acidic gases. We know that different type of gases are released from burning of the fossil fuels in the refineries or through the burning of fuel in the engine of automobiles. They give rise to different type of pollutants like sulfur dioxide, nitrogen dioxide, carbon dioxide, and ammonia, hydrogen sulfide, and carbon monoxide into the atmosphere. And when they reach the upper atmosphere, they give rise to acidic rain. And they also give rise to the fog, which is one of the major problems in today's world, and especially in the China, we have observed this type of problem. And these gases also create severe climatic changes such as greenhouse effect and global warming. So these MOFs are very interesting and very useful candidates to absorb such type of acidic gases and air pollutants, so can be used as important materials for environmental remediation. Next, I will proceed my presentation on crystalline and ionic germinate covalent organic frameworks and their different type of applications. And this is the major concern of my research work. Why I used germanium in these type of frameworks. Since germanium was discovered in 1886, it's been used in different type of as a semiconducting material in different type of devices like transistors, light emitting diodes, solar cells, and optical fibers. Germanium is also found in the nature in the form of organogermanes, and these are some organic complexes of germanium with these compounds. and they are also synthesized in the laboratory and also present naturally in the nature. And some of the germanium is also found in the form of porous inorganic frameworks like GeO4, GeO5, and GeO6 in the form of mixed inorganic cluster systems and some zircogermanates. So it shows that germanium is found in the nature, as well as it can be synthesized in combination with different organic, inorganic material in the form of hybrid material, and it has a large number of applications. The first COF which I have synthesized by using this germanium and a combination of germanium and some anthracene-based linkers, I have devised the first crystalline anionic germanate covalent organic framework, and its backbone was composed of germanate, and which was linked through the covalent bonds to the linear ditopic anthracene linker, and it also contains the lithium ion. So this COF shows exceptional properties for carbon dioxide adsorption and the selectivity. Here I have displayed the cover feature of my work, and it was published in 2019. How I synthesized these COFs, I have divided it into two parts. The first part is concerned with ligand synthesis. The second part is concerned with the COF synthesis. In the ligand synthesis, I have synthesized the anthracene ligand, which is a ditopic linker, and it is divided into two steps, which are very easy. And after the synthesis of the ligand, I have just used this anthracene along with germanium oxide, and I have synthesized these extended 2D COFs. The methods which I have used for my synthesis are solvothermal synthesis and microwave synthesis methods. Both of these methods were employed under inert atmosphere, because inert atmosphere is very important for the successful condensation reaction. In the presence of air, the oxygen and germanium bond is destroyed. So the crystallinity of the framework is affected if we don't use the inert atmosphere. So inert atmosphere is very important for the synthesis of such type of framework and COF material. The important difference between the solvothermal synthesis and microwave synthesis is that all these steps are same. The only difference is the reaction time. In case of solvothermal synthesis, the reaction time was 96 hours. That's why I have used the microwave synthesis to reduce the reaction time to 6 hours, while the temperature in both cases which I have used is 180 degrees Celsius. This is the structural design of my COF, and it has a backbone with germanate nodes connected to the ditopic anthracene linkers, and they are surrounded by different alkali metal lithium cations. And I have named this COF GCOF1. It is lithium-based COF, and the second one, this is the pore diameter, which is 1.5 nanometer of this COF, and the figure C shows the pathway of the lithium ions through this extended framework. I have characterized this new COF through different characterization techniques. The first one is FTIR. The second is the other powerful and major characterization technique, which is usually used for the COF and MOFs. It is solid state NMR. The third one is the PXRD. And the morphology was examined through the scanning through transmittance electron microscopy. In transmittance electron microscopy, it shows a leaf-like morphology, while scanning electron microscopy shows a flower-like morphology of these COFs. As these COFs also contains the lithium ion, which has a high affinity for different type of gases, and these COFs have a reasonable pore diameter and pore volume, and it was analyzed through nitrogen adsorptions. This COF shows reasonable adsorption of nitrogen and a surface area of 808 meters square per gram, and the pore and the analysis of its pore width and pore volume shows that this material is microporous. This material contains the lithium ion. That's why I have examined it for carbon dioxide adsorption, because lithium containing materials have affinity with the acidic gases like carbon dioxide. So I have checked the carbon dioxide adsorption at different temperatures, starting from 273 Kelvin, and at 219 Kelvin it shows the least adsorption. And it also shows high affinity for carbon dioxide, which was proved through the isosteric heat of adsorption of 38.36 kilojoule per mole. And after analyzing the selectivity of carbon dioxide over nitrogen, it shows that this material has a high selectivity of 101, which is among one of the best among different COF and MOF materials. The important property associated with any new material is its chemical and thermal stability. So chemical stability was analyzed by soaking this COF in different solvents, and after immersing for 24 hours in these different solvents, I have observed no change in their PXRD pattern. And as we know that carbon dioxide has acidic characteristics, so some of the MOF and COF materials show network degradation after adsorption of such type of acidic gases. So after adsorption of carbon dioxide, I also analyzed its PXRD pattern, and it shows no difference in the PXRD before and after CO2 adsorption. It means that this material just absorbed carbon dioxide physically. There is no chemical adsorption of carbon dioxide within this framework, and there is no network degradation. So this can be used as a future material for adsorption of carbon dioxide. As the framework contains the lithium ions, so I have analyzed it for lithium ion conductivity also, and to be used it as a solid state electrolyte in different ionic batteries. So for this, I have used this electrochemical workstation, and when I analyzed its ionic conductivity in the pristine state, as in the pristine state there is no solvent, so their ionic mobility is hindered. So I have introduced some of the organic solvents like ECDC, ethylene carbonate and diethylene carbonate, which is a very common organic solvent used in different type of lithium metal salts. So after soaking in it in ECDC's electrical lithium ion conductivity was enhanced to 10 times as compared to the pristine material. And after impregnation and after infiltration with different alkali metal salts, especially lithium PF6, this COF material shows conductivity enhanced in the conductivity 20 times as compared to the pristine material. And activation energies shows that these COFs in pristine as well as in infiltrated form have a very low activation energies, which make them suitable for the ion conductivity applications. And it also have a reasonable transference, lithium transference number of 0.65. I have made comparison of this lithium-based COF or GCOF1 with the different reported COF materials, and it shows that even in the pristine state, this material is a good candidate for conductivity applications, and it don't need the incorporation of a large amount of external lithium salts. That's why I just incorporated 20% of lithium-based salt, and it also shows a reasonable transference number. In summary, this lithium-based COF or GCOF1 can be synthesized through very easy method, and the introduction of germanium in this framework gives rise to 3 types of advantages. The first advantage is increased in the pore width. The second advantage by introduction of this heavy germanium element within this framework is that the ionic mobility is enhanced. And when ionic mobility is enhanced, this conductivity is increased. So this is the second plus point of introduction of this heavy element into this extended framework. And the third important outcome of the introduction of the germanium within this framework is the enhanced CO2 uptake capacity. Next, I will discuss about the second part of my work, and I have synthesized the same COF with same backbone, but I have introduced the versatility within this structure by introduction of different type of lithium metal cations. In the previous part of my presentation, I have talked about the lithium-based COF. Here I will talk about the sodium and potassium-based COFs. So these COFs can easily be, their structure and properties can easily be changed by just introduction of a single alkali metal cation. And by varying a single alkali metal cation, its properties can also be enhanced and varied. The synthesis steps are same as I have discussed before. It is a single step process, and it involves the use of this ditopic anthracene linker with germanium oxide, and this can be carried out through the solvothermal synthesis and also through the microwave synthesis. And these GCOFs are formed through the reticulation of a linear ditopic linker with octahedral germanate nodes. And here, just increasing the size of the alkali metal cations, their ion conductivity and their absorption capacity for different gases is enhanced. So versatility was introduced within this framework through introduction of different type of alkali metals by using different type of alkali metal methanolase salts. These frameworks were also characterized by the different type of characterization techniques like FTIR, PXRD. And here I also shows the topology of this framework, and this framework has a honeycomb-like structure, which I have shown here in this slide. And this is the side view along 100 direction, and it also shows the different ionic channels and pathways. These COFs were also characterized through solid-state NMR, which is a very powerful analysis technique used for different type of structural analysis. Like my previous part of my presentation, where I have used lithium-based COF and has analyzed its surface area. Here I have also analyzed the nitrogen adsorption for sodium and potassium-based COFs, and both of these COFs shows higher surface area as compared to the lithium-based COF. In case of sodium-based COF, the surface area is 1050 meters square per gram, while in case of potassium-based COF, the surface area is 1252 meters square per gram. And both of these COFs, like the previous lithium-based COFs, has almost equal pore width of 1.5 nanometer. In order to check the practicability and in order to check its suitability for different applications, it is important to first analyze its thermal and chemical stability. So I have checked the thermal stability through thermal gravimetric analysis. These COFs shows a high thermal stability, and the network degradation starts after 450 degrees Celsius. And in case of chemical stability, I have soaked these two materials, that is sodium and potassium based COFs, into different solvents. Likewise, lithium based COF, these two COFs also shows no degradation or retention of their framework even after soaking in different solvent for 24 hours. Like lithium-based COF, sodium-based COF has also alkali metal cations. So I also have analyzed for carbon dioxide adsorption. In case of sodium-based COF, the carbon dioxide adsorption increases with decreasing the temperature, and similarly in case of potassium-based COF, the carbon dioxide adsorption also increases with decreasing the temperature. And as we increase the size of the metal cation or counter cation within these COFs, their affinity for carbon dioxide is increased. This is because by increasing the ionic size, the polarizability is enhanced. So their interaction with these acidic gases is also increased. And Na-based GCOF shows 37.2 kilojoule per mole of isosteric heat of adsorption, while potassium-based GCOF showed 32.3 kilojoule per mole. I have also analyzed them for carbon dioxide selectivity over nitrogen. In case of sodium-based COF, the selectivity of carbon dioxide over nitrogen was 137, while in case of GCOF K or potassium-based So no cough has been used for such a breakthrough or dynamic adsorption of sulfur dioxide under the Q gas condition. So we need to synthesize the new material that can efficiently absorb sulfur dioxide, and they don't show the network degradation after the adsorption, and they can retain their structural integrity. That's why I have employed the DG cough for sulfur dioxide adsorption, because it already showed a reasonable carbon dioxide uptake and selectivity. And so I have a device. I have created a device which is composed of these different type of the elements which are connected together and are shown here in this schematic diagram. The sulfur dioxide and nitrogen dioxide cylinders were connected through these lines, and their concentration was mixed and then passed through a mass flow controller, which was connected to two columns. One was packed column, and it was filled with powder cough. The second column is the blank column. First, these mixed gases were in the different ratios were passed through the blank column, and when a certain type of stable concentration is obtained, then we closed this blank column and then open this valve of this packed column. And these gases, when fall on the spectrometer, they give rise to different concentration, which was recorded on this PC, and it was generated in the form of different graphs. Through this type of schematic, through this type of apparatus, I have analyzed the breakthrough capacity of my coughs. These are different breakthrough results which I have obtained under different SO2 concentration and after mixing it with nitrogen. The first picture shows the breakthrough results at a low ppm of 50 ppm, and the second one shows the breakthrough results at a higher concentration of 500 ppm. In both of these cases, the flow rate was maintained at 100 ml per minute, and these coughs show a good recyclability over 5 cycles. So it means that this cough can easily be used efficiently be used for 5 desorption cycles. And in order to check the effect of different flow rates of these gases passing through these packed columns, I have used different flow rates. By increasing the flow rates of gases passing through these columns, their interaction with the adsorbent or cough material is decreased. So increasing the flow rate decreases the interaction with the adsorbent, interaction between adsorbent and adsorbate. As a result, at 100 ml per minute or high flow rate, I have got the results with low adsorption, while at low flow rate of 25 ml per minute, there was a high interaction between adsorbent and adsorbate. And as a result, I got the maximum results, adsorption results. The important aspect about these frameworks is that they have retained their crystallinity and their structure even after the adsorption of sulfur dioxide, which means that there is no chemical interaction or chemical adsorption of sulfur dioxide within these frameworks, and they maintain their crystallinity, which make this material very useful for practical applications. Their PXRD was retained even before and after the SO2 breakthrough test, and in the IR, the major peaks also remain the same. So the structural integrity was maintained even after the adsorption of this acidic gas on the surface of these coughs. In the scanning electron microscopy and transmission electron microscopy, images also showed that there is no structural degradation, there is no change in morphology before and after sulfur dioxide adsorption. So I have made a comparison of these 3 coughs, which is the first one is the lithium-based cough, second is the sodium, and third is the potassium-based cough. And among these coughs, the potassium-based cough shows highest CO2 uptake and highest selectivity for carbon dioxide. And when I have made the comparison with other recently reported material for SO2 uptake, I have concluded that potassium-based cough has the highest adsorption capacity for sulfur dioxide under the breakthrough condition. So sulfur dioxide can be the next material for so the potassium containing GCOF might be the next material for efficient sulfur dioxide adsorption and to create some type of sensor devices to sense such type of acidic gases. Here I have made comparison of these 3 COF materials with the already reported COFs. So it shows that these materials can adsorb high SO2 even under low concentration like 500 ppm, whereas the previously reported materials, they have adsorption at a high concentration level of sulfur dioxide like 2000 ppm and 1%. So these COF materials are very sensitive for sulfur dioxide, and they can be used under low ppm condition as well. Like lithium containing GCOF1, these 2 COFs which contain sodium and potassium ions have also reasonable ionic conductivity, which was also tested through different type of ionic conductivity tests. And in the pristine state, their conductivity was relatively low. So I have soaked in propylene carbonate solvent. When I soaked, and then the ionic mobility was increased. As a result, their activation energy was also lowered. So these materials are also important candidates for conduction of sodium and potassium ion, can be used in the sodium and potassium ion batteries in the future. Here I have made comparison of these sodium and potassium based COFs with some previously reported materials. Previously, rarely there have been any COF which have been reported with sodium and potassium ion conductivity. So these 2 materials are the first material which can conduct sodium and potassium ion even in the pristine state, and their conductivity is comparable with some of the MOF materials which incorporate sodium and magnesium ions. In summary, GCOF now are sodium containing GCOF and GCOF-K are potassium containing GCOF have 3 important characteristics, because they have sodium and potassium ions, so they can conduct these ions and can be used as important ion conducting materials in the sodium and lithium potassium ion batteries. Potassium containing GCOF-K have a high capacity for carbon dioxide and a high selectivity, so they are very efficient carbon dioxide adsorption material as well. Among these COFs, potassium based GCOF-K has highest SO2 breakthrough capacity at a very low SO2 ppm level, so they might be the future material for sensing such acidic gases. These are the conclusions and future outlooks. This GCOF is the first series of COF which is based on the heavy non-metallic element, which is germanium. Germanium has rarely been incorporated in any type of COF material previously. So framework diversity can easily be introduced by varying the alkyl chains on the anthracene linker, or by varying the different type of alkali metal cations. So here, as I have explained, I have used a different type of alkali metal cations to introduce different properties and to introduce the framework diversity. And these can accommodate a variety of cations, so they can also be versatile candidates for different type of gas adsorption and ion conductivities. They can be future candidates for adsorption of some acidic gases, so can also be used as acidic gas sensors in a different type of sensing applications. And they contain lithium, sodium, and potassium ions, so they can be potential solid state electrolytes in the future batteries like sodium and potassium ion batteries. Finally, here I have compiled some of my publications. In the end, I would also like to mention the name of my research group and my professor who lead this research group from Beijing Institute of Technology, and who is also one of the famous student of Professor Umar M. Yaghi. And our research group is mainly concerned with the designing of the new materials and their applications for batteries and for environmental remediation. And I am really indebted, and I will especially thank to the VC of Dawood University of Engineering and Technology, Professor Dr. Faizullah Abbasi, and Pro VC Professor Dr. Abdul Wahid Bhutto, and Dr. Sajid Sensial, Chairman, Department of Metallurgy and Material Science, and Engineering, Karachi. Thanks for your attention and listening. So if you have any question, you can ask.
Thank you very much, Dr. Shumaila, for your
yes, sir.
Classic presentation, and you define each and everything very clearly. Those who are know all about the MOF and energy storage devices, then they can easily, I hope, I'll get benefited from this presentation. If you have,
yes, sir.
Anybody have a question? Any question from audience side? Hello? Okay, Dr. Shumaila, thank you very much. You give us so much tough time. Even it's very difficult for us. We will cope these things in the future. And
thanks a lot. Sir.
We are waiting for a question. We are
yes, sir.
Also taking 1 minute if we get.
Okay, so can we use these kind of material as you have used for the gaseous removal of the gaseous form of these ions? So can we use in the aqueous system, or it is more suitable for the gaseous system?
No, we cannot use it in aqueous system because aqueous or water is not suitable for these type of materials, and they degrade when we use some moisture, and only we can use some organic solvent to enhance its conductivity. We cannot use any aqueous environment because when we use organic solvent, the ionic mobility is increased. We don't need to use any aqueous environment.
Okay, thank you very much. Thank you. Very nice presentation.
Thanks a lot, Amna.
Thank you, Shumaila. Have a nice day.
Thanks a lot, sir.
To evening, and I'm going to invite another presenter here.
Yeah.
Thank you. And,
thanks a lot, sir.
Now it's time to Dr. Muhammad Sufiyan Javed, a postdoctorate researcher at the Jinan University, China. And I invite you, sir, here on this multinational symposium. So, सर मेरी आवाज आ रही है आपको सुफियान साहब? हेलो सुफियान साहब मेरी आवाज आ रही है?
Yes, I can hear you. Thank you very much, Prof.
Okay, welcome you, sir.
Yes.
And I'm giving the whole stage to you. Please present your work and engage all our audience with you. Thank you very much.
Thank you very much. Thank you very much.
Sir, over to you.
My screen is there.
सर आपकी स्क्रीन शो कर रहे हैं. ओके
Me?
Sir, can we share your screen here of your presentation, if you allow us?
I can share here. Is okay, I think so.
You have shared screen and we can see your presentation. Please, sir, you can continue.
Okay. Thank you very much. Today I am honored to present my talk at a National Multidisciplinary Symposium on Advanced Technologies and Allied Fields. And my name is Muhammad Sufiyan Javed, and I am currently doing postdoctoral research at Department of Physics, Jinan University, Guangzhou. And today my presentation talk will be about senses of low-dimensional nanomaterials for energy storage applications. The contents of my talk will be covered the introduction to nanomaterials, research background, result and discussions, in which I will show some synthesis methods of different kind of nanomaterials for energy applications, and after that I will conclude my talk and talk about future outlook and conclusions. Introduction to nanomaterials. We have various kind of nanomaterials such as 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional nanomaterials. In 0-dimensional, we have core shell nanoparticles encapsulated in hollow nanospheres, and composite nanoparticles. In 1-dimensional nanomaterial, we have carbon nanotube-based composite electrodes, coaxial nanowires, and composite nanowire arrays. In 2-dimensional nanomaterials, we have graphene-based composites, carbon-coated nanoplates, carbon-coated nanobelts, and in 3-dimensional nanostructure, we have mesoporous composite electrodes, macroporous composite electrodes, and future 3D electrodes. Some properties of low-dimensional nanomaterials such as graphene, molybdenum disulfide, tungsten disulfide, vanadium disulfide, and molybdenum selenides and other selenides. These materials are assembled by layer assembled nano architectures with 0, 1, 2, 3 dimensions. Research background summary of 2-dimensional nanomaterials. There are various kind of 2-dimensional nanomaterials such as layered oxides, 2D carbons, 2D cylinders, and semiconductor materials, and some metallics. In layered oxides, we have lithium cobalts and molybdenum trioxides, and in carbon-based material, we have graphene, reduced graphene, and molybdenum disulfide as a semiconductor, and indium selenide and thallium sulfide and titanium sulfides are the 2-dimensional famous materials. And these materials have lot of applications in optical, magnetic, thermal, catalysis, energy storage, and transport properties. Applications in transport. And new 2-dimensional materials is known as metal carbides and also known as machines, and this can be metal carbides and nitrides. And we have a max phase of these materials, and in which we etch the one phase and we got some nano sheets like structure. Here we can see that this is the max phase. Max phase is layered tertiary carbides, nitrides, and carbonitrides consisting of MAX layers, and by the treatment of HF hydrofluoric acid we can selectively etch the A layers from the max phase. Then after etching the A phase, then we known as machine sheets, which is 2-dimensional structure. This is SEM images of the etched 2-dimensional nanosheets of titanium carbide. And other kind of materials, 2-dimensional metal organic frameworks. Metal organic frameworks are a class of compounds consisting of metal ions or clusters coordinated to organic ligands to form 1, 2, or 3-dimensional structures. MOFs can be synthesized in a variety of morphologies, and single atom-based material can also be derived from MOFs. MOFs also have so many types, and also has lot of applications, such as these has some excellent properties: good flexibility, abundant active sites, tunable structure and function, high porosity, high specific surface area, and high aspect ratios. And these are used in broad applications such as catalysis, energy storage, sensing, gas adsorption and separation, and lot of any other applications which is used as MOF materials. Then I am moving towards the background of supercapacitors. In 1995, the first supercapacitor is used in electric cars, and further in 2004, Shanghai High-Tech Park developed a fast charging system along with the first supercapacitor bus in the world. And further in 2006, the first commercial bus line in Shanghai was launched, and further in 2009, the supercapacitor was developed for hybrid electric vehicles by Nanotechnology. And in this area, nowadays we are focusing on the flexible supercapacitors to meet the commercial applications, gadgets such as mobile phones and similar other applications, and we want to replace the battery with supercapacitors. These are some scenario about trends and forecast of the global supercapacitor market. In 2014, we have just only $0.6, and in 2019, the global market increased by 15%, and it will be expected 2025 increase in 20%. The opportunity of supercapacitors, product type, voltage, and use dusty. The electrochemical AA supercapacitor is used less than 25 volts. Pseudo capacitor can be used at 25 to 100 volts, and hybrid capacitor can be used above 100 volts. And these are the companies, famous companies that is working on the supercapacitor technology to make it in market, such as Maxwell, Cap, XX, Panasonic, and some others. And the application is supercapacitor in transportation, industrial, energy, consumer electronics, and some others. The key challenges and properties in battery: we have high energy but high weight, cost, charge, speed, lifespan. In supercapacitor, we have less energy density, which is the main target for supercapacitor to enhance the energy, while other parameters are very good, such as lightweight, low cost, charge speed is very high, lifespan is much better than as compared to battery. So these are the strategies to increase the energy density of the supercapacitor. First, we need to increase the capacitance, and other is to increase the voltage. For increasing the capacitance, we need high surface area, high pore size, high functional groups, and much high electrical conductivity of the material. Then we increase the capacitance. And on the other hand, if we focus on the increase the voltage of the device, then we need to use organic electrolyte, ionic liquid electrolyte, or use the asymmetric supercapacitor design, or some battery supercapacitor hybrid technology. Next, I am moving towards my typical results and discussion section. That is, I will introduce some synthesis of metal oxides, metal sulfides, metal selenides, carbon, graphene, and machine, and MOFs, and their use in supercapacitor or battery applications. First is the single metal oxides. In single metal oxide, I choose the vanadium oxide, vanadium pentaoxide nanosheet for flexible zinc ion batteries. And figure A and B, we can see the low and high resolution SEM images, in which we can see that the thickness of the nanosheet is around 3 to 5 nanometer. And next image is the TEM and with mapping, indicating the only vanadium and oxides present in this material. Next is the XRD and XPS spectrum, and this material is used for the flexible zinc ion batteries, and this is the typical performance of the zinc ion battery. We can see it can run very frequently, up to 60 cycles, and it has very good stability. And this is the crystal structure of the vanadium pentaoxide nanosheets, and this figures on the right side of the slide show the flexible nature of the battery and bent at various angles. And this is the practical performance of these batteries, and it can be light by bending two batteries and lighted the over 50 LEDs. Next, we also did some charge storage analysis of these material as a zinc ion storage, and we can see that it has high capacitive performance as compared to diffusion control process. Furthermore, we have some in situ XRD analysis, in situ Raman spectroscopy, and these the charge discharge performance, and further confirmed by the in situ XRD and XPS and TEM analysis. Next, bimetallic oxide, in which two-dimensional zinc iron oxide ultra thin nanosheet for all solid state flexible supercapacitor. This is SEM images. First image is the bare carbon cloth, and the other images are the zinc iron oxide grown nanosheets on the carbon cloth. And in this work, we did some DFT calculation to find the diffusion path for lithium ions, and we successfully find that there is two paths exist for the tunneling or diffusion of the lithium ions, and one path has low diffusion barrier about 0.4 electron volt, and other one has greater diffusion coefficient about greater than 0.6 electron volt. And this is the systematical assembly of the device, and we use the lithium chloride LiCl as electrolyte, solid state electrolyte, and these devices can be run and practical applications, and more than 10 LEDs can be lighted by 3 supercapacitors connected in series. Another work is also bimetallic oxides, in which I prepare zinc, cobalt, nanopolyhedrons for all solid state flexible superclusters. This work is also binder free electrode, and we can see the low and high resolution of the material. And this one also is flexible. We can bend at different angles, and these three devices can run the LEDs, and this has high energy density and power density as compared to other recently published work. And other work is the three-dimensional cobalt molybdenum oxide flowers. This is a systematic illustration for the fabrication process of the electrode material, and this is SEM and TEM images, and this is the aqueous electrolyte supercluster. Previous one is flexible solid state. This one is aqueous. The assembly of the supercluster is just similar to lithium-ion batteries, in which we use anode and cathode and some electrolytes. And these two devices connected in series can light to LEDs. And it has much better energy and power density as compared to other previous work. Another is layered structured metal sulfides. This is SEM and TEM images of the MOS2 layered structure materials, and this is also used for supercluster, and it possesses very good performance. Another work is also layered structure tungsten disulfide at nanocarbon composite for aqueous lithium ion storage. This is the systematical illustration for the fabrication of the material, and other is the charge, discharge, and cycling stability of the material as the lithium ion battery anode. Another one is non-layer structure transition metal sulfides, in which is zinc cobalt sulfides, nanoparticles locked in and doped graphene carbon nanosheet derived from metal organic framework for all solid state supercluster. This is the systematical illustration for the synthesis process of these nanosheet materials, and this is SEM and high resolution SEM images. And this is device assembly, and this device also can be bent at different angles, and it show very good performance at bending different positions. And interestingly, this device can light two LEDs by single device. And this is another manganese sulfur nano spheres for all solid state supercluster. This is systematical illustration. This is also binder free electrode, and we can see the low and high resolution images, and this is the nano spheres. This is the CVD CV curves, and this is the capacitor and diffusion control process, and we see that the capacitor performance is lag as compared to diffusion control process, and this is the charging discharging behavior represented by the graphical presentation. Another work is tunnel structured three-dimensional iron sulfide nanospheres for all solid state supercluster. In this work, we also did some theoretical calculation to find the potential barrier diffusion path for lithium ions hopping, and we can see that it has about 0.5 electron volt for lithium ion. Another work is one-dimensional copper sulfur nanowires for all solid state supercluster. We can see that the SEM and crystal structure of this material, and other is the flexible performance of this kind of material, and it shows very good performance as a supercluster device with high Coulombic efficiency. Another work is three-dimensional manganese selenide microflowers for all solid state supercluster. This is the systematic illustration and SEM and mapping, and this is the solid state flexible device, and it is the symmetric device, and both electrodes, anode and cathode, is made by manganese sulfur and carbon cloth, and this the symmetric device can work up to 1.8 volt, and it has much better performance up to 5,000 cycles. Another work is the graphene nanosheet, mesoporous diffective graphene nanosheet for all solid state supercluster. This is the systematic illustration for the fabrication of these typical nanosheets, and this is SEM and TEM images and the device performance. And this device has much better results as compared to all other previous reported devices, more than 10 and it has a better energy and power density. Another work is two-dimensional nanomaterials titanium machines. And this is the first is the synthesis process of the machine nanosheet, and this ABC is the max phase and the other etched phase of machines. And we can see that the CV and GCD, and it shows the better performance, about 97.52% after 10,000 cycles. Another work is two-dimensional zinc cobalt MOS for all solid state supercapacitor. This is the SEM images, low and high resolution of the MOS, and it has typical polyhedron like structures, and this is the supercapacitor performance, and it shows very stable performance up to 5,000 cycles by retaining the 97.15% after 5,000 cycles. Another kind of material is the low-dimensional atomic layer deposition, in which we use V2O5 as a backbone, and we coated TiA2 by using atomic layer deposition. And we can see that the mapping, from the mapping, the layer of the TiA2 is about 5 to 10 nanometer in thickness, and we see its zinc ion performance is much better as compared to pristine one, and it shows very stable performance as compared to pristine V2O5. Next is some publication as first author and corresponding author, and among them one paper is very hard paper and highly cited on the Web of Science, and it has about greater than 200 citations. And currently I am also working as a topic editor in Frontiers in Material Energy, and our topic is MOF-based nanomaterial for energy storage applications. And in same journal, another issue is going on, porous nanomaterial for superior energy storage devices. And I am also working as guest editor for International Journal of Photo Energy, and also editorial board member of International Journal of Material Science and Applications. Overall, I have published about 98 research articles, in which about 35 papers are published in first and corresponding author, and average impact factor of first author paper is greater than 5, and some papers are published in very good journals such as Nano Energy, Journal of Applied Electrochemistry, ACS Applied Material Interfaces, Journal of Material Chemistry, Nanoscale, Journal of Power Sources, Chemical Engineering Journal, and Electrochemical Acta, with over 2,500 citations. And at the end, I am very thankful to my professor, Banje, who is advisor of my postdoctorate at Jinan University and Postdoctoral Science Foundation of China. And this is our nano energy group at Jinan University, and all people are very happy and very helping with each other. And thank you very much. And I am also very thankful for this opportunity to Dr. Sajid Hussain Syal, who invited me to present this talk. Thank you very much.
Thank you, Dr. Javed Sufiyan. Thanks a lot. I request of the participants, if someone want to ask any question. Sir, Itej.
I feel some problem in my laptop, so I switched to here and other.
Okay, no problem. So, thank you very much too.
If somebody have a question, okay, one question from 20mm48. Yes. Sir, we have very little question from your side. Okay, you can ask this question now.
Yes, you can ask.
जी किसी के पास है कोई सवाल? Thank you, Dr. Sufiyan sir, for your time and attention for Dawood University, and your contribution really highly appreciated for us. And now I would like to invite Engineer Dr. Ahsan Ejaz, Assistant Professor, Department of Civil Engineering, Mirpur University of Science and Technology, Azad Kashmir. So
thank you very much, Doctor. Also, thank you very much too, and nice to meet you. Thank you very much.
Thank you, sir. Thank you so much, sir. So kind of you.
Thank you.
Over to you, Dr. Ahsan Ejaz sir. Dr. Ahsan. जी डॉक्टर एहसन साहब। एहसन साहब आपको मेरी आवाज आ रही है? आप अपना माइक जो है वो ऑन कर दें प्लीज। हेलो डॉक्टर एहसन। हेलो डॉक्टर एहसन, मेरी आवाज आ रही है आपको?
Can you hear me?
Yes. Okay.
Okay, that's fine. So let me to share my slides, then I will continue.
Okay. Yes.
I'm just trying to share my slides. So myself, Dr. Ejaz, and prior to be here, and it's nice to see again the Dawood Engineering University. I was the student there at the Dawood. At that time, it was Dawood.
आपकी आवाज, हेलो एक्सक्यूज मी एहसन आपकी आवाज जो है ना डॉक्टर साहब, ये उसका थोड़ा सा इश्यू आ रहा है हमारे पास कि आवाज क्लियर नहीं है, ये आवाज डबल हो रही है आपकी। तो
okay, I manage. Is it okay now?
No. We have a question from Yunus Physics that, well sir, how we can use metal oxide for energy as well as environmental application?
Previous question that which
Okay, ऐसा सब आपकी आवाज
Is it okay? Should I start? Can you hear me properly?
Yes, now it's somehow very nice. Okay, you can
Okay.
over to you.
I was introducing myself. I'm Dr. Ejaz, and nice to be here again at the Dawood Engineering University because I am the fellow of Dawood Engineering. At that time, it was a college back in 2010, and I graduate from the Department of Metallurgy and Materials Engineering. Later on, I did my Ph.D. From the Shanghai University, China, and from 2016, I am working as an assistant professor at the Mirpur University of Science and Technology. And our today's topic is about effects of hydrogen.
Ahsan, again, sorry to interrupt you. Can you open? नहीं, यहाँ पे स्क्रीन जो है वो थोड़ी बड़ी कर दें। स्क्रीन बड़ी छोटी नजर आ रही है आपकी, उसको फुल कर दें। प्रेजेंटेशन मोड पे लेके आए हैं, या जो हम मोस्टली करते हैं कंट्रोल F5 करते हैं। जी
Sir, is it okay?
Yes, continue.
Okay. So, in our today's class, we will discuss about the background and objective of why hydrogen and how hydrogen can damage nuclear materials. And then there are experimental results. Somehow we will discuss the emergent test. And then there are two different techniques that I have used for the studies. And the first one is electrochemical measurements. And then the characterization that how the surface has been damaged by the charged hydrogen into the different materials. And then we will discuss there are two different the effects of hydrogen on the anodic solution and passivation in iron in alkaline solution. And the second one we will discuss the anodic solution passivation and especially pitting behavior of iron in bicarbonate solutions. And at the end, I will discuss the summary and the future work. And I will request you, I will encourage you to discuss if you have any kind of idea in your mind to accelerate this process in the future. Okay, here you can see this is your left side is the nuclear power plant in the whole. There are different sections, and on the right side there is only one. That is basically the steam generator that is used once there are, the temperature at the nuclear power plant is very high. So steam generator is basically used to cool down the water or the steam that is generated in the nuclear power plant. So basically the process is once the very high temperature hydrogen, or you can say the steam coming from the nuclear power plant, it damages the plant or the material, because hydrogen atom is very small, so it can easily penetrate into any kind of material, even though we are using high nickel chromium alloys in the nuclear power plant. But still, hydrogen itself can generate the space and can penetrate or can dissolve into the nuclear power plant materials. So how and why hydrogen is critical, we will discuss the whole lecture. The first thing, what are the source of hydrogen that can be
Ahsan, आपकी slides जो हैं वो move नहीं हो रही डॉक्टर साहब. आपकी slides जो है ना वो I know कि you are talking from the Azad Kashmir और वहाँ पे थोड़ा नेट का इशू है, might be possible. Again, अगर आपकी slides जो हैं वो थोड़ी move हो जाएं तो it's very comfortable for us.
It's not moving because it's working okay for me here.
From your side it's okay, but our side we are not catching your slides are.
Doctor, kindly, if you will share it again, please cancel the sharing and share it again. It will be able to move the slides.
Okay, let me try again.
Yes, Doctor.
Hello, Ahsan.
Yes, I'm sharing the PPT again. Just
I have a solution. Agar aap, I want to connect you on a phone and you can show your slides on this screen. It's okay. I can connect you on the mobile phone. Okay.
let me try once. So after that, we can share even on the mobile.
Okay.
Another one.
Doctor, hello, you can see here the steps of sharing the screen. That, for example, we have this screen, you can see. At the top of that section, you can click on that button. So there will be some options wherefrom you can share your PowerPoint presentation. And if this button is crossed like that, so just push it and again share it again. So it will be able to show on the screens again.
I'm doing again. So
there are two options are there at the bottom of that screen. One is the screen sharing and second one is the PowerPoint presentation. So you can both select the screen share or the PowerPoint screen, PowerPoint presentation, and after that you can select your PowerPoint presentation.
hello. मैंने स्लाइड सेंड की है सर आपको व्हाट्सएप पे सेंड की आपको वो अपलोड हो रहा है अभी मैं एक मिनट में बताता हूँ